Let's look at the equation x squared divided by 4 plus y squared minus z squared divided by 4 is equal to 1. Let's figure out the shape of this quadratic surface. So let's start by determining the yz trace. So what is the yz trace? Well, you plug in x to 0, you plug in 0 for x here, so that then what you get is y squared minus z squared divided by 4 is equal to 1. Now this is the equation of a hyperbola, where the hyperbola opens or extends along the y-axis. So here is the yz. Here is the yz trace. The yz trace is this. Yz trace consists of the two green curves here. So that's the hyperbola. And then the xy trace is an ellipse given by this. So the xy trace is an ellipse where the vertices of the ellipse would be at the points where y is 1 or minus 1, and the other two vertices are along the x-axis at 2 and minus 2. And so now let's look at the traces in planes parallel to the xy plane. So in this plane z is equal to k, what's the trace? Well, when z is k, we plug in k for z here, and then if we do that, we get this equation. So if I put a k here and then put this term on the other side, this is what we get. So we see that when the trace is an ellipse in the plane z is equal to k. Now when k is 0, you get the trace in the xy plane, which is this one. And for, you know, as k gets bigger and bigger, as k gets bigger and bigger in absolute value, this ellipse gets bigger and bigger. So you can see that. So remember, the green curves are the yz trace. That is, the green curve here is the hyperbola here, and the pink ellipses are the traces in planes like this. So then the question is, so then you can see what is the graph of this equation. So you get a surface that looks like this. It kind of looks like, I don't know if you guys have seen nuclear power plants. The surface of a nuclear power plant looks like this, and this is called a hyperboloid of one sheet. Okay, so generally the general version of this equation would be x squared over a squared plus y squared over b squared minus z squared over c squared is equal to 1. And the graph of any equation of this form would be an hyperboloid of one sheet, that would be hyperboloid of one sheet that extends along the positive, that extends along the z-axis. Now, if let's say instead of putting a negative sign here, I put the negative sign in the middle here, well, then I'm going to get a hyperboloid of one sheet, but it's going to be extending along the y-axis. And then if I have the negative here and the other two are positive, then I get a hyperboloid of one sheet, and it's going to extend along the x-axis. Okay, so that's an hyperboloid of one sheet. In the next video, we will be looking at hyperboloids of two sheets.